All right, so video everywhere. Sorry? You're on video everywhere.
I'm on video everywhere.
All
okay, nice. Welcome everyone to the PhD defense of Mr. Anders Gravholt, who has written a thesis called Fatigue and Gait Decline in Adult Cerebral Palsy, Pathophysiological Determinants and Contribution of Targeted Physical Activity. For the ones who are not accustomed to these type of academic events, I will start by introducing the jury, the committee, and also the supervision team that has worked with Anders these past years. My name is Ferdinand von Walden. I'm a professor at Karolinska Instituttet in Stockholm. We also, and I'm part of the, I should say, we also have Professor Gija Rackauskaite from Aarhus University, also part of the committee, and Hureau, social professor, Université Strasbourg, also a committee member. From the supervision team, we have close associate Maître, professor here at the university. We have co-supervisor Annemieke Boyser from Austria, and Bruno Fernandez, medical doctor here, and Lapole, main supervisor. We will now start by having Anders present his work for us, 45 minutes. And after that, the committee will ask questions, 25 to 30 minutes each. We will start with Gija. I will follow. Thomas will finish up that questioning. Before we then leave the word to the supervision team, this is your one and only opportunity to ask Anders questions on his work in front of an audience, I would say. So take that chance. There's no stupid questions today. We will have asked all of those first. So take that shot. Yeah, I was going to say, for a Swede, we're already late, but in France, we're just on time. So Anders, take it away.
Cheers. Thanks, and hi everyone. I'm very happy to see you. I've been looking forward to having 45 minutes of uninterrupted talking time about what I've been doing for the past 3 years. Namely, investigating what happens when you grow older as an adult with cerebral palsy when we're looking at fatigue and gait. What is cerebral palsy then? If we look at the two words, they might not translate that well for all of you, but we can translate it into something more edible: brain paralysis. So now we know where in the body we have an issue: brain. If we look at the definition, the one from the NIH, for example, then we see that cerebral palsy refers to a group of neurological disorders that appear in infancy or early childhood and permanently affect body movement and muscle coordination. We also have definitions in Danish, Swedish, French, whatnot. Slight differences between the different definitions. Cerebral palsy is the most prevalent childhood onset disorder. I say onset because from the definition we see that it happens in infancy, as in right before birth or during birth, or you can have it as acquired cerebral palsy happening in the first couple of years of life. You also note that the map has darker areas and more blue areas, with prevalence differing based on country GDP. We also saw that it's a group of neurological disorders. As such, cerebral palsy is an umbrella term for a lot of different disorders that can be subcategorized. We talk about unilateral, affecting one side of the body, or bilateral types of cerebral palsy, where both sides, maybe only the legs, are affected. We also talk about different motor types. in adults, you'll see that different areas of the brain might be affected. The most common being the spastic subtype, where you'll see tense muscles, you'll see stiff muscles. Then we have the dyskinetic, where the word might give a hint. It's something to do with involuntary movements. We have an ataxic form that affects your balance, your positioning in space, or we can have a mixed form, where you get a bit of everything. You might have seen this guy before. It's the homunculus proportioned after what area of the brain is responsible for what part of the body. That might help you in understanding what damage might lead to cerebral palsy in what part of the body. If we look at the motor cortex, you'll notice that the facial expressions, hands and genitals take up a large part of the motor cortex. Arms, torso, legs, feet take up a much smaller proportion. If we look at the spastic subtype, which is the one I'll be primarily interested in today, we see that on the left we have a form that only affects one side of the brain, then the contralateral side of the body is affected. We can have the spastic bilateral form, where both sides of the brain is affected, but you also notice that it's primarily the area that affects the lower limbs that is affected in this example. Then we have probably the most severe form, the bilateral form that affects upper body, lower body, everything. Gross motor function is typically how we describe the level of mobility amongst adults or children with cerebral palsy. It's a 5-level system, with the level 1 being the people who are the most mobile, 5 being people who are bound to a wheelchair. You typically get your classification when you're a young child, and you maintain that throughout life. I've mentioned it here because we're primarily interested in those who are level 1 and 2 at the age of 18. What does it look like then if you have cerebral palsy? Here we have an example of a patient who at the age of 18 is GMFCS level 2 and has now gotten older. I'll try and show you a gait. You'll see that it's not super stable. The walker is necessary, and you might notice some contractures that can be seen in limbs that do not have full range of motion, for example. As a child, we see a lot of physiotherapy, we see a lot of surveillance. You'll note here that children in white see a physiotherapist. Most of them see it at least weekly, if not more. Amongst adults, this changes. We see a large proportion never seeing a physiotherapist. We also see that the older study might not be relevant anymore, but the study from 2021 says something similar. Fewer visits to the general practitioner associated with age. Why is that important? Well, I'm talking about becoming an adult. Becoming an adult comes with fragmentation of care. We see less surveillance. A simplification of the pediatric care system is a system where the child goes to one center to cover all their needs. When they become adults, they might have to go to several centers for each and every specialist. They might have to talk to insurance. They might have to navigate bureaucracy. We also see in the scientific literature that the amount of studies amongst adults with cerebral palsy just last year is what, 1/5 of the studies amongst children. So there's a lot more surveillance amongst children, both from a scientific point of view, but also in the healthcare system. Growing up with cerebral palsy comes with a lot of issues. For example, pain. It's very prevalent. Here I'm showcasing a study, very recent meta-analysis, wherein the authors have included all the studies they could find that lived up to the inclusion criteria, and they weighted each study to give an estimate of the global prevalence of pain reported by adults with cerebral palsy. You'll note that the estimate is not 0, it is 70%. 70% of adults with cerebral palsy experiencing pain in daily life. Pain and fatigue goes well together. Here we have a participant aged 16 complaining of pain leading to bad sleep, leading to fatigue. We've also seen that co- and multimorbidities are an issue amongst adults with cerebral palsy. Here, a patient registry study included 1 million people, wherein 2.3 thousand of those had cerebral palsy. They found that adults with cerebral palsy, 86% of them had a medical disorder, 60% had a neurological disorder, and 50% had a mental disorder. Even worse, 36% of these people had one from each of the 3 categories. That means they are not only experiencing comorbidities, but multimorbidities. This compares to 3% in the background population. We're going to talk about walking. Here, an example from participant 1, saying, well, I used to be good at walking, I'm paraphrasing here, but now I'm getting tired and I'm falling. I'm starting to think of using the wheelchair more often to avoid having to fall all the time due to fatigue. Aging is similar to that. We have Louise complaining about aging, saying that, well, I feel like I'm aging quicker than typically developed peers, possibly through forcing your body above its limits or past its limits. The last part of the definition said something about permanently affecting body movement and muscle coordination. Here on the x-axis we have age, and the y-axis we have mobility, with 100 being that of a typically developed child. We have the different GMFCS levels and their expected mobility, and you'll notice that most of them at the age of 8 starts to plateau. That would be pretty good. You're not experiencing a decline, but you just get to a plateau. Amongst adults, it looks different. We see that the proportion of adults not experiencing a gait decline starts to rise or fall very quickly from the early to the late teens through the 20s. Already in the 20s, we see that the proportion not experiencing a gait decline is close to 50%. Only getting worse from there. One of the important studies for the creation of our protocol was the one from Ferdinand and colleagues. Here, 126 participants were invited to help assess what can predict your performance in a 6-minute walking test. 6-minute walking test, it is as simple as it sounds. You walk for 6 minutes as far as you can. They found that 39% of these participants had experienced a gait decline. And they found, interestingly, that estimates of performance, unadjusted, yes, were age, strength, and balance. They also concluded that future studies should investigate all these factors with a large sample size and in a longitudinal design. But tested the gross motor function part of this in a longitudinal design. Here they invited a young and a slightly older group, we're still talking very young people, assessed their gross motor function and invited them back in 8 years later. You'll note again, 23 and 31% had experienced a gait decline. Quite damning. This leads us to my first objective. Quantify age-related differences in mobility amongst adults with cerebral palsy. I think you might agree with me that my hypothesis that 10 years of difference in age will lead to a measurable decline in mobility. To assess this, we included 14 young people and 16 older people, half of them with cerebral palsy, and the other typically developed peers matched for age, height and weight. The younger group, 18 to 25, older group, 35 to 50. Inclusion criteria include that you have to be GMFCS level 1 or 2, have bilateral spastic cerebral palsy. To answer our objective, we used the 6-minute walking test. We used a 10-meter walking test, where you had to walk as fast as you could for 10 meters. That is probably from here to here. Time up and go, a measure of indoor agility, standing up, walking 3 meters, around a cone, returning to the seat. And finally, to include a measure of balance, the back balance scale, with measures such as standing on 1 foot or standing with your eyes closed. We found measurable differences in the timed up and go and in the 6-minute walk test. If we include the participants, might be too small to see, but you'll see quite a large variation within the older adults with cerebral palsy, but not amongst the younger. We'll also see that the results are very similar to those seen in a similar population. So it's not like our participants are very different from those we see in the literature. Finally, Eric from this laboratory tested the same amongst 80-year-olds and found that 80-year-olds could walk longer and could transfer quicker. To give an idea of the severity of the 10-meter walking test, I have here a crossing in Copenhagen and a traffic light. We have the 4 groups. From the left, older adults with CP, and you have the light on the left. You'll note that, okay, it might be an exaggeration with the traffic light because even the runners do not pass, but everyone else gets to go across the street before getting trampled by bicyclists, but the older adults with cerebral palsy. The results are similar to what we saw in the other objective measures of gait decline. Lastly, I promised you a balance test. Here, the dashed line is the maximum score, and even with a ceiling effect, we see a significant difference between younger and older adults with cerebral palsy. To better understand what could be at work here, we conducted a narrative review, finding in red things that are worsened compared to typically developed peers at the time of writing, and the arrows indicating a worsened evolution with age compared to typically developed peers. We also sadly found that 1 and 2 stars were the only level of evidence we could provide, with 1 star being low level of evidence and 2 being medium level of evidence. We wanted to investigate a couple of these different aspects of mobility or mobility-related measures. 7, we want to investigate fatigue, muscle strength, mobility, cost of walking, VO2 or cardiopulmonary function, voluntary activation of your muscles, and fatigability. This leads to the second objective of my thesis. Investigate factors associated with mobility. Again, I think that the hypothesis is very fair. We're expecting a faster decline in gait-related measures compared to the typically developed population. To do so, we wanted to employ a 4-visit protocol, 18 people in each group. Each day was filled to the brim with testing, approximately 2 hours per visit. For participants, the first day concerned our first objective, mostly, but also measures such as the cardiopulmonary exercise test to test VO2 max. Second day included another walking test, some strength measures, and a quantitative gait analysis that I've sadly not finished treating, so I won't be talking about that today. Finally, third day, we had the oxygen consumption during gait. What does it cost to walk 1 meter? And the fourth day, a test of neuromuscular fatigability, but we'll get to that. I said we wanted to have 18 people in each group and did not succeed. We included participants from all of the Loire region, everyone who could fit our inclusion criteria, and most of our participants do not drive. So 1 hour drive from our center probably translates to 2 or 3 hours of public transport. Happily, we received funding from the University Foundation, allowing us to transport participants to and from the lab, at least shortening the time it takes to be a participant in my study. Looking at said participants, we see no differences across the board for height, weight, BMI, but we do see a difference in age, which is not surprising given the two age groups. Let's move on to the first 3 visits. To quantify activity, we used watches that allowed us to measure movement in 3 dimensions. And we asked participants simply, do you feel fatigued? How much time do you spend exercising? And how is your physical and mental well-being? For the last, we used the short form 36. With regards to the actigraph measures, we saw no differences in steps walked per day. You might argue that they don't walk that much. We could also say that our matching of participants is very good. They slept the same, no differences there. But we did see that our older adults, when we subcategorized the type of movement, moved more in the light intensity domain compared to younger participants, and more in the moderate compared to young, typically developed participants and older adults with cerebral palsy. With regards to the questionnaire on fatigue or chronic fatigue, we found that the older adults with cerebral palsy were more fatigued than all of our typically developed population. If we look at the graph, I added a dashed line. This dashed line indicates clinically severe chronic fatigue. If we add the participants, we see that a couple of them are touching or below the line. So fatigue is a serious factor amongst our participants, or at least some of them. We saw no differences in the 2 other questionnaires, indicating that the self-reported measure and the actigraphy reported measure on physical activity is similar between groups. We saw no difference in the short form 36 either. To test cardiopulmonary function, we used bikes and an incremental fatiguing test. You see that we used 2 different bikes due to a requirement of an ECG during stress for the healthy participants with cerebral palsy, but not amongst the others. We used the same metabolic card, and the measure of interest was oxygen consumption, peak oxygen consumption. So I do not believe that changing the bikes impacts the measure. Again, we see, well, for once, we don't see any differences. We see that, some of our participants with cerebral palsy have quite a low VO2 but it might be due to constraints in movement on a bike. We also see that our results are very similar to what can be seen in the literature. And if we compare to Eric's older adults, they are better off compared to 80-year-olds. Moving on to cost of walking. We used the 6-minute walking test with a mat to assess overground walking at your fastest speed. Then we used the treadmill to investigate 3 different speeds, 100% being your preferred walking speed, and then at faster speeds than that, 120% and 150% of that. We found a doubling of the cost of walking 1 meter per kilo of body mass when walking during the 6-minute walking test, but only amongst the older adults with cerebral palsy. We saw no difference between younger adults with cerebral palsy and the typically developed peers. The same was true when walking on the treadmill. Here we saw one massive outlier, possibly due to normally walking with a cane, and now walking, holding onto a transversal bar in front of them, changing all of your biomechanics and everything you've learned. When increasing the speed, we saw the same picture, but no real difference in cost of walking. Moving on, we tested strength because we figured this must be important because Clayton said so. We tested it isometrically, that would be in a static condition, and then we tested it in series of 3 contractions at a slow pace, the one shown here, and at a pace that was double that. We tested several muscles, leading to quite a lot of results. So let's look at a more simplified version. We tested the hamstrings, quadriceps, and the plantar flexors because we believe they were interesting for gait, but also because they are accessible to measure in a very controlled manner. We found that older adults, but not younger, were statistically significant in all measures compared to the typically developed population. They were not stronger. We also found that the younger adults with cerebral palsy were stronger in a lot of measures, but not all. We saw that for the hamstrings during slow dynamic movements, there was no difference. Statically, for the quadriceps, no difference. And for all dynamic measures from the plantar flexors, we saw no difference. That leads us to the 4th visit, test of neuromuscular fatigability. And you might be thinking, fatigue, what? We've talked about chronic fatigue. We assessed it through questionnaires. We can assess it through interviews. It's something that is chronic and is not relieved by rest. Neuromuscular fatigability, on the other hand, is something acute following a piece of work and is normally relieved by rest. It's something that we can measure through volitional effort or using stimulation techniques. We could go about that using maximal voluntary contractions. Here, the participant will be tasked with contracting the muscle as much as they can. It comes with the issue of motivation. To circumvent this issue, we can start using electrical stimulations. Here, a similar attempt, but with superimposed stimulation and a stimulation at rest. Superimposed meaning we stimulate, you'll see it in a second, contracting all you can, stimulate and rest. And then we get a second stimulation. What does that help us to understand? It helps us to understand the pathway to neuromuscular fatigue. We talk about a central system from motor cortex that you saw was affected amongst adults with cerebral palsy through the central nervous system and until the spinal cord. Then we have a peripheral aspect from nerve to muscle fiber. And lastly, we have the global measure that includes volition in the maximal voluntary contraction. Testing this is typically done through a protocol where we assess the maximal voluntary contraction with no stimulation, because stimulation is a bit scary. Then we start testing the same neuromuscular evaluation that includes a maximal contraction, a stimulation, and a stimulation at rest. That means that we have the maximal voluntary contraction, we have the peripheral part because we have a stimulation at rest. But where's the central part? Well, that can be evaluated based on the effect of the stimulation superimposed onto the maximal voluntary contraction. Here we can use the difference in force and multiply that by the force just before the stimulation divided by the maximal force obtained and divide that by the peripheral measure through the stimulation. Normally in the literature, at least for cerebral palsy, when investigating fatigability, most of it has been done using maximal contractions. They would here used 4 30-second maintained contractions to force fatigue amongst participants. They used the maximal force capabilities. The same was true for Moore, who used dynamic contractions, something that might be closer to everyday life and how you fatigue yourself, but still maximal voluntary contractions. Finally, we have Stackhouse, who used electrical stimulation. And you might think, okay, there's no volition in here, but it was still based on your capabilities. Why is that important then? Well, if we're testing someone based on how much they can contract their muscles, we're also testing them based on their capabilities, but not based on what they want to do in daily life. If I'm riding up Mont Ventoux and I weigh 100 kilos, it's going to be a lot harder than for Pogacar, who weighs 60. Which is why we employed a design that used your body mass as the determinant for the increased intensity in stages. We believe it's more ecological to have a setup that is dependent on your weight rather than your maximal capabilities. Also, if you want to transfer this into daily life, like walking. So we used weight as a determinant of intensity for each stage, and after each 3-minute stage, we conducted a neuromuscular evaluation. We continued this until the participants could do no more. We did it on an instrumented bike. We used the same stimulation as you saw in the video before. Then we measured the activity in the muscles. We used that primarily to assess how much stimulation we needed. And we used pedals on a bike that could get blocked with a force transducer within. So we could go from a dynamic movement straight to an isometric neuromuscular evaluation. How does that look then? Here we have a willing participant who pedals away. In a second, you'll see that I block the pedals. He starts contracting, and on the right, you'll see the force trace. And if you're really good at counting, you'll note that it was less than 3 seconds from end of stage to start of neuromuscular evaluation. Let's look at the baseline data. We saw that, once again, for maximal voluntary contractions, the older adults with cerebral palsy were weaker than everyone else. If we look at the data, individual data points, and we consider what has been seen in the literature, this is not surprising. But again, we see no difference for the younger participants with cerebral palsy. Looking at the peripheral test at baseline, we see that the muscles locally are also weaker amongst older adults with cerebral palsy compared to everyone else. Again, very similar to what can be seen at baseline in the literature. Finally, for the voluntary activation, the central component from brain to central nervous system or spinal cord, we see that the older adults have a significantly lower voluntary activation compared to typically developed peers, but not compared to younger peers. We also see quite a large variation in data. If we include a recent study conducted here on the same bike, but amongst older ladies by Mathilde, we see that the voluntary activation amongst older ladies is slightly higher than that of our participants. To recap, we see lower force, lower peripheral localized muscle force, and lower voluntary activation. Moving on, if we look at the common stages performed, where everyone has done a similar piece of work dependent on their weight, we see an immediate drop in the volitional force, as in the global aspect of force, amongst the older adults with cerebral palsy, through all the 4 first common stages. Significantly different at all but one time point. We see individual data points being fairly narrow, not too much variation. Looking at the twitch force, it doesn't tell us that this difference comes from localized muscle differences. Instead, we see quite some variation in the ability to locally fatigue the muscles. And finally, if we look at the relative difference in voluntary activation, we see some differences in some stages, but not in all. If we're looking at all the data, you'll again notice that there's quite some variation, with a couple of our participants really losing the ability to activate their muscles fully. To recap this, we see a great immediate loss in maximal voluntary contraction after one stage, and this first stage was easy. It was pretty much like a warm-up. We also see that the path to fatigue appears to differ due to a lower initial voluntary activation, but also quite a large variation within the adults with cerebral palsy. Talking about the number of stages completed, it was very low amongst the older adults with cerebral palsy, not significantly different between the rest of the participants in the study. If we compare to the older ladies, we see that they completed at least 4 stages, all of our participants, but not much more than the average amongst 80-year-olds, using the same protocol. If we start to look at task failure, on the other hand, we see no differences. I see this as something very positive, because then everyone has been able to fatigue themselves, at least volitionally. Everyone pushed themselves until an actual task failure that was similar between groups. It doesn't look like that if we look at the twitch force, the peripheral adaptations. Here we see differences between older adults with cerebral palsy compared to the typically developed peers, and something that might look like a difference amongst the younger peers, which would indicate that they're not able to fully fatigue their muscles locally, but they reach the same drop in voluntary force. Finally, for the voluntary activation, we see no differences. So that doesn't necessarily explain why that is. In summary, at task failure, we see that the groups observed the same relative loss in volitional force and in voluntary activation. But we see quite a large difference in the peripheral adaptations, and we see fewer stages completed. So the total work done is less. To summarize this visit 4, we see an earlier immediate force loss amongst older adults with cerebral palsy, fewer stages completed, and a greater ability to locally fatigue muscles amongst typically developed peers. This leads us back to the objective. Investigate factors associated with mobility. And if we look at an overall view of our findings, I would argue that we find a difference in selected or self-reported measures through questionnaires. We don't find any differences in the objective measures of activity. We find differences in the mobility measures, but no difference in VO2 max. Finally, balance. We can talk about it. I didn't test it amongst typically developed peers, but we would assume that every one of them are able to move about freely and obtain the maximum score. For strength measures, we saw a large difference between the older adults with cerebral palsy and pretty much everyone else, or almost all measures. The cost of walking doubled, with a minimum difference of 10 years and an average difference of 21 years. Finally, fatigability was largely different, with the volitional effort decreasing very quickly amongst older adults with cerebral palsy. If we're looking back at the overview from the narrative review, I believe that a lot of these factors must be associated. We're seeing increased fatigue with aging compared to the typical developed population. This must be linked to the cost of walking 1 meter. There must be a lot of interplay between a lot of these different factors, explaining why fatigue is such a big problem. Pain as well. If you have trouble sleeping every night, well then fatigue is going to be prevalent in the population. If we're talking about muscle strength, then sarcopenic tendencies is important. We can observe differences in the quality of muscle with increased fat infiltration, a stiffening of the sheath around the muscle, and contractures and stiffer tendons, leading to possibly more force to overcome just to walk. All of this, of course, plays into mobility. And funnily enough, we didn't find a difference, like most of the literature, with aging. And that's why I have a question mark there still. I simply do not know what happens with the cardiopulmonary system with aging. Is it worsening at a faster rate, or is it due to how we measure it? Finally, fatigability. I don't believe we have had any measures before that indicated a difference between typically developed peers and those with cerebral palsy. But I do believe that it must be linked to voluntary activation, possibly how the spinal cord is made up, and of course to all the measures concerning your muscles. So, what should be done in the future? In a perfect world, I would like to repeat this protocol with the same participants every 5 years. It would offer a super resolution of what happens when you grow older. We have these, on average, 20-year-olds that we could follow for, say, 20 years and really understand what is the main issue. Is it fatigability? Is it cost of walking? What worsens quickly with aging? Interventional studies would make sense. I would like to do something that is not just a training intervention, but something that offers a sense of belonging, maybe in a club where you would go and have a community and want to be there, not just as a physiotherapist. Because we saw in the beginning, these adults, they don't go to the physiotherapist. So maybe the interventions that are similar to that, they're easy to control for, but I'm not sure they're going to work in the long run. Finally, epidemiological research would be an interesting avenue to explore, to try to see if we can explain some of the differences through, for example, the amount of physiotherapy different generations experience over time, or simply try and answer, do the operations you receive now as a young person lead to fewer visits to the general practitioner later in life? But that is for future. Last thing, I'd like to thank all my participants. No participants, no studies. They really put in a lot of effort. You might think, oh, it's only 4 visits. But if you're coming from 2 hours away, you spend 2 hours getting here, you spend 2 hours with me, and 2 hours getting back. 4 times for nothing, because they get nothing from this. Obviously, my supervisors, I think I've tested your patience in a lot of ways. I've learned a lot, and I've been very happy to be here in France. It's not only because of you, because I have fantastic colleagues here. Super nice. That is all for me. Hope you want to speak up.
You can speak that out. Right. Thank you, Alex. Now we're moving into the questions from the committee. And we said we start with Professor Gija. I mean, we're foreigners here, so we're going to do this a little bit different. Gija has progressed in slides.
Yeah, I'll just be a boomer for a second. There you go. Let's say I do like this. It shows up, and you get this.
Thank you. I really enjoyed the presentation. It was some of things that I have been trying to find out. It became clear for me. And I'm a neuropediatrician, means that I follow these children with cerebral palsy for 17 years. And then I tell them they need to contact the general practitioner for the further lens. And for the last 2 years, I was able to tell them, yeah, something is on the way. There is a project in Denmark in one of the hospitals close to Aarhus, where they're trying to find out what kind of follow-up should be for the adults with cerebral palsy. And there's another project in Copenhagen for young people with cerebral palsy to ask them what do they need? Because we see that these teenagers, they don't like these annual follow-ups. They don't want the parents to be there all the time, not all of them. They don't need 1 hour to talk to pediatrician and orthopedic surgeon. They have other issues going on in their lives. So when you come back to Denmark, there is a lot of work for you to do. So my questions will be from the neuropediatrician's point of view. And this is a lot of quite different field compared to what you have been doing. So, but I think there were some questions I wanted to ask you. And it's not an exam, it's a discussion. So I want you just to relax and try to answer, and then we can have discussion, my point of view and your point of view, and yeah, and so on. So I will start with this slide that you have shown. You've shown another version of that. And this is the original slide. This is original slide about how mobility of children with cerebral palsy is going on. And you can see the GMFM, it means General Motor Function Measurement. It is an item, and you have 100 points, you're able to do everything what a 5-year-old child can do. It means you can jump on one leg. So, and on the bottom you can see the line, which goes up to 21 years, and this is a Canadian original study, and they saw this decline in function for people who are not able to walk by themselves. But GMF's level 1 and 2, the ones that you have studied, they continue until on the same level. And there is a new Swedish study. Another one was from 2009. They published in 2023 the study with the lines that are equal. They don't see decline. So my question to you, Anders, is which one do you believe is true?
Well,
You want to discuss
yes, I mean, I showed the study from Hureau, who showcased that early teens, late teens, they saw a decline. It's possible that in some countries you might not see this decline, but it really seems that everyone with the data we presented here, but that there's something important happening from your early 20s to 30s. And okay, both of the graphs only go to the age of 20. It's hard to say, but because they obviously done their work,
Yes.
so it must be true. It's not showing all the variation within data. And I've seen the graphs that show all the variation. And this is a gross simplification of the data. And you'll see that there's so many who might improve or might experience a decline. This, yeah, I think it's from 6,000 people or so.
Yeah.
And very, very narrow. Well, they're not showing the variation within data.
This was 600 people with 3,500.
Okay,
And this
yeah.
one, 2,000 people with 5,000.
And obviously, when we have our sample of 30 people, we could be unlucky and only have those who do not experience a gait decline, or those who do. I think that there must be something happening, at least around the age of 18, where the change of, I discussed it in the thesis as well, the change from going to a school system where everything is incorporated and you have a fairly easy life, and then going to having to navigate, walking around, going to work, going to school, going to university, or maybe living by yourself, will end up requiring more energy. We spoke about it yesterday, that the task of walking for a lot of people with cerebral palsy is something that is not a subconscious task. For example, when I'm walking forth and back here, it's subconscious. I'm just doing it. But if you're moving away from your parents, if you're moving away from a very stable system where you know where everything is, then I believe that they might still be capable of living up to the test at the hospital. But in day-to-day life, they might start walking with a cane because it's simply less mental fatigue. But I'm not sure.
Yeah, and there is there is no clear answer for these ones. And problem with both of them, there are very few participants on the age after 15 years.
Yeah.
So these they are not so reliable after in the teenagers when you look on the raw data. So I don't think that any of them is correct. And maybe it's not the most important thing. When you are 18 years old, it's important for you to walk. If you are jumping on one leg, maybe it's not so important.
No, and they might be good at getting tested. They've been tested since they were 2 years old.
Yeah. So it's all kind of mobility. It's not just walking, but you have been testing the things that on bicycle and walking. Yeah. So I don't have the clear answer as well.
No.
So both of them are correct, but both of them lack data on the adults. They're very few. So this measurement they used, this is a kind of measurement of gross motor function, very used in neuropediatrics and also sensitive to see the changes in children. So have you ever considered to use this in your study?
I think we had a brief talk about it, but we chose not to because we used the GMFCS as base inclusion measure. And what we aimed to do with the study was to give an estimate of if we have people who are comparable at age 18, what happens when they're older in terms of what we can quantify. The GMFM, similar to the back scale, will be in some ways subjective, sorry. Like the back scale, okay, you could argue, okay, there was a bit of touching with your foot while you were standing for 30 seconds. Do we give it 3 or 4? The same could be said for this. And I would have to learn to use it properly.
And you have to have a license.
Yes, and I have none of those things, and I don't know what the value of adding it would be.
Totally clear. I don't see any value adding it to you, but it just when you see the literature of aging, and people use that. So if you want to continue the studies and doing research, continue the way the neuropediatricians and physiotherapists have measured aging of development in motor function, they use this. So maybe some other methods should be used when you measure aging in the adult population, or maybe it would be nice to use that. I don't know which method is correct.
No.
Just to get you don't forget this measurement because it's very used in pediatric neurology and cerebral palsy. So I'm totally right. You don't need that for your study.
It's also
maybe it can help you to classify if it's really GMF as 2, or it was about being 3 or 1, because now you can have a scale where you put, if the person is on the 15th percentile on GMF. That could be the only one help.
But it's probably half an hour extra.
You don't need, that's a good choice. And then you have chosen to measure the strength of the most affected leg.
Yes. I knew that this question would come. Part of it was time constraints. We could have measured in both legs, but every measure was statically, dynamically, and dynamically. It takes half an hour to do this test with setting up the isokinetic dynamometer, with moving participants, and with giving them quite a lot of rest in between trials. And we figured, well, what is the limiting factor in terms of strength for these participants? Is it the leg that they can rely on, or is it the leg that is causing the most issues? It could be of interest to test similarities between legs, but I still think that the most effective leg is the one that's limiting you the most. And I think we discussed that in length, whether we should add a fifth visit to say, okay, then we test both legs properly and see what is the difference. Instead, I hope that we can see differences in the 3D gait analysis, where we have measurements of leg activity. So maybe we can see some differences in the synergies between muscles, between legs, and also in the variation of the movement of the leg. But
yeah, I can see that this was the right choice as well. But then when you measured fatigability, you measured on the right leg.
yes, and again, this is obviously a problem. The bike.
You learn things when you do PhD, yeah. So
no, but it's the bike with a crank.
I understand your choice of choosing the right leg on the bike. So if you do it again, will you test the right leg in all the participants from the beginning? What will that affect the data?
I don't think necessarily that the measure of strength at baseline on the bike is an important measure to bring about. I'm more interested in the evolution of fatigue. And yes, you could argue if there's a large difference between the muscles of the most affected and the least affected leg, then it's interesting to investigate. But seeing as we tested the most affected leg in everyone, we have that measure as well. And the test of fatigability then tests, okay, how does the muscle fatigue over time? But if I could magically have the bike be measurable on both sides, that would be nice.
Yeah, that would be nice.
But it's simply a equipment constraint. Because yes, of course, with half of them being on their weaker leg and the other half being on the stronger leg, can you compare it?
Okay, don't think it. Thank you for the answer. I just wanted to have a discussion about you. I was sure that you have considered it a lot of times, so I just wanted to hear your considerations about it. And then you measured at different kinds of fatigability.
Yes.
And in that version of thesis that I have been reading, I was a little bit in doubt. Where does the peripheral nervous system is in this kind of classification, what kind of fatigability it is? Because at one place you say that peripheral is just the muscle, and then I saw the slides today, that is nerve fibers, they are in the peripheral. So can you please explain me again what kind of fatigability and how you classify it? I
included in the slide the nerve because that's where we stimulate. So when we stimulate the nerve, we cannot rule out that there's an issue in the nerve when we test the muscle. But the nerve is activated fully. We are sure about that due to the EMG electrodes reaching a plateau. And the nerve then activates the muscle. So it's the muscle that we're interested in, and it's what happens in the muscle that we try to assess. But I included the nerve because that's where we stimulate. And that's where the test stems from.
And this voluntary activation, is it everything? or is that kind of overall fatigability, or
Sure, you
I'm
can
not sure.
say that. That's where my supervisors come in. But really, we try to split the system up between what happens locally in the muscle, where we have an objective measure of it, and then what we can infer from what you can push versus say you activate your muscle, and then we stimulate and you get a large extra force. Then obviously you are not fully contracting your muscle. We have this here, so I might as well use it. But say we have a force measure here, and we have a maximal voluntary contraction. This is the volitional part. And then we have the stimulation. In most of our participants, it will give something like this, basically nothing. But we also saw that the stimulation at rest gave something like this, like a small peak. If then we see a large increase due to stimulation, then there must be something going on from the signal being sent from the brain and all the way to the muscle.
So if they release, then you can.
That's them. If they don't really push, then we would have an idea of it. My participants being super nice, they actually pushed. But we could see that at task failure with the volitional force. Okay, they might have faked all that, but I don't think they can.
This comes to the next question. This trying, of course, you can have questionnaires, and then you have that subjective, how the person feels, how fatigue he is or she is.
Yeah.
But then you try to measure it, and when you measure it, how can you find out which part of it is peripheral and which part is central? Because these are people with central nervous system damage. So
yeah.
If we need to give them coaching or trying to, you cannot repair the damage that happened 30 years ago,
yeah.
but where should we go? Should we try to coach them, or should we ask them to train the muscles? Yeah, so that's why it was interesting for me. How can you find out what you measure, central or peripheral fatigability?
Well, we saw that they are the older adults, or adults in general with cerebral palsy, appear to be unable to really fatigue their muscles locally to the same extent as you and I. Which could stem from not being able to maximally activate the muscle to begin with. Because while we did not see any difference in the relative voluntary activation, we have to remember that the voluntary activation at baseline is quite a bit lower, meaning that if our estimate is correct, which I have an inkling it might be, then they are from the get-go unable to activate fully activate their muscle. And if they're unable to fully activate their muscle, then they cannot fatigue all of their muscle. So I think it might stem from central difference causing downstream effects that look like peripheral fatigability. But we also didn't see any big change in the voluntary activation. So it's not like the brain gets more fatigued or stops sending signals to a larger extent than the rest of the typically developed population. But they might just start from a lower activation, meaning that if they cannot activate 100% of the muscle, they cannot fatigue 100% of the muscle.
So you measure the peripheral fatigue in your study, but because they have the quite low production in the beginning, they relatively activate lowly. You think that both of them are issues?
I think there's some interplay between them. But again,
But you only measure the peripheral, and because you.
But also
Yeah.
if we talk about the central as the voluntary activation,
Yeah.
if we set an equal sign between those two, then I also think we have a measure of that.
But
It's dependent on the stimulation.
Mhm.
So everything is tied to stimulation, which is fun.
Do you think it's possible to stimulate it on the brain?
We could, and I think I might have proposed that we test with magnetic stimulation, we test with stimulation up here. Yeah, it hurts like hell. Then we test stimulation in the spinal cord, and then we test here in the on the nerve, and maybe even directly on the muscle. That, in my mind, we could have these stimulations measure the electric signal at every point, and then we could see if the conduction velocity of the nerves are a limiting factor, or if it's simply sending the signal from the brain that is the limiting factor. I'm not sure this is all feasible, or that I can find anyone who will submit to it, because that's more stimulation than I've ever done to anyone. But it would be very interesting.
Thank you for the discussion. Yeah. And then this is your words. Co-contraction in antagonist muscle could affect the calculation of voluntary activation.
Yes.
Yeah. So my question is, was it not possible to measure this antagonist during exercise, during pedaling?
It definitely should be. What we experienced was that due to the seat being quite large on the bike, every time you started pedaling, you would touch the electrode and cause a lot of noise. But it could be done if you go on a normal bike. Then you could easily place the electrodes, or if you place the electrodes maybe further down, but you could only do it on the larger people, or taller. So yeah, it's super annoying that we cannot do this, because I would really like to have a measure.
There were some constraints that you were not. Yeah, it was not because you were not thinking about them, but it was not possible.
But it would be fun.
And why do you match by BMI and not by weight? Just weight.
Ooh, did I write both BMI and weight?
You read that it was by BMI, but maybe it was by weight.
I used the weight and the height.
Yeah, you used the weight
and the height.
Yeah. But you have written at some place that it was by BMI.
Yeah.
So my question is not yet if you matched by weight. So because I was asking, because in one of the every now when you present your results, there is a table one. I thought that your young participants, they were only 52 kilos of weight, but that's a mistake. So we just go further.
And we saw it the other day because
yeah. So just skip this question because
sorry about that.
Yeah. This is because I made the slides before I saw the presentation. Yeah. So back to the fatigability and the results. We have a conclusion about earlier fatigue that is likely the result of greater central alteration. So what do you mean by these central alterations?
We saw during the common stages that there was a significant difference after stage 1 and 3 in voluntary activation, but not at fatigue, in the relative decrease in voluntary activation. With more participants, this might be true for everyone, or it might be that a subpopulation of adults with cerebral palsy worsened their voluntary activation. We had participant 5 and 2, I think, worsening very quickly after the first stage. And all of them saw this rapid decline in maximal voluntary contractions, as in what they could do themselves. So the idea would be that we saw no difference locally in the muscle, but we saw these differences in the relative decline in voluntary activation. And those might, in part, explain some of the acute differences following a piece of work, but they couldn't explain it at the end. Because
So you mean, is this from the central nervous system, or what do you mean this central autonomic?
I think that there might be some sort of constraint when you start working, as in you start pedaling, and you get assessed right after. Because the first stage is super easy. We're talking, you're biking downhill from the hospital to the inner city. You're doing nothing.
Yeah.
But still we see a decline in force. And this decline in force we couldn't explain by the
strength of the muscle.
the twitch, but we saw it measured in the two other systems.
So we see something about coordination of movements.
Maybe the mental aspect of having to do a task that you're not
Used to.
familiarized to, because they only got to test it very briefly during the first day, where they also went through a lot of tests, and it was the last visit.
So maybe we just need to explain also when you try to make the article, because I do not understand what you mean.
I think we have some work to
Yeah,
do
some work to
in explaining what happens there.
Then young adults with sleepy, they experience less fatigability and task failure, highlighting the need for elevation up to the maximum task. Now I understand this sentence better when you explain everything. But was it an unexpected finding for you that they do not have so much fatigue, the young ones?
If it's dependent, if your pathway to fatigue is dependent on the injury to the brain, then I would say that it's unexpected that young adults do not exhibit the same as old adults, because it's an acute injury to the brain, or it's an acute issue, cerebral palsy, and we think of it as something that is permanent, but not necessarily declining in severity. So it's quite interesting to see that the younger adults are able to maintain a similar workload to typically developed peers, and which is why we're also patting our shoulders and saying, "Oh, it's very smart that we investigate after each stage." But it's I don't know. But because if we look at the literature, Neywood did not find any fatigue after the fatiguing task. Hureau found very similar fatigue at the end. And Stackhouse, I cannot remember exactly what the graph looks like, but I have it with me if we want to look at it. I still find it unexpected that simply 20 years of age alters the pathway to fatigue so much.
That can change the pattern of the fatigue.
But I don't know, and that's why it would be interesting to repeat multiple times.
Thank you. Let's skip that. Now I want to talk about pain.
Yep.
Yeah. You found, that's really true that your fatigue would affect your mental health, but that is also known that pain also affects the mental health.
Yeah.
And here, when you ask these 15 participants, you can see that bodily pain is as prevalent in all the populations.
Yeah.
So, can you please come? Do you have any comments on that?
It's obviously very contrary to the literature, with 70% experiencing pain all the time.
So what do you think the reason is that your measurements
are like that?
Yeah.
They might be very hardcore people.
Or maybe the questionnaire is not sensitive enough to see the differences. I think it doesn't ask how badly that pain is. No. It's just how often it is.
Yeah.
It's not the best instrument.
Not at all. I know, but it's.
But the quality of life is really good.
Yeah.
So just the instrument is not sensitive.
It's I must admit that questionnaires are not my strongest point.
But it just when you submit the paper, I think somebody will ask you, so just to get prepared for the reviewer's comment. Yeah, this is not, And I will skip this first question. So I would like to discuss this one.
Yeah.
You comment on this Cochrane review that is 5-6 years old, and that we had no training interventions to improve muscle strength. The training interventions that improve muscle strength, but not functional measures. So are there some new training interventions that improve the function?
Feels like there should be. I cannot remember reading anything about adults, but definitely amongst teenagers and kids.
Yeah.
We see Busboom, for example, finding quite a good effect on power training. I don't remember if they improve function, because definitely they improve.
And they did, but when you train the strength, the way they train the strength was walking the stairs, and then you get better walking.
Yeah.
So when you train walking, you get better walking, and maybe can explain a little bit more. But to train walk, to be better in walking, we need to train walking. It's not enough to train strength. So there are a few studies that show that. So if you do some mobility intervention, let us visit what kind of outcome measure will you use?
Yes.
We wanted to do some interventions, so
yes. I still quite like the idea of the 3 tests we used, the 10-meter walking test, ecological, something that tried to reflect what is life with cerebral palsy, not what is the most, how can we compare? Because if we want to compare them, we have to take muscle biopsy to look at the differences. But if we use body weight as the determinant, then we're looking at I would say, more functional measure of mobility, because again, I normalize the cost of walking to body weight, not a strain of walking. That would showcase, well, okay, if you weigh this, the cost goes up, but the cost is fairly constant. If you want to go on a bike, or if you want to go on a frame runner, the cost probably goes up with weight, even though your muscle, even though you have less muscle per kilo.
Do you think it would have been fairer to normalize to amount of muscle?
Well, we're testing populations in their functional capabilities. So normalizing to amount of muscle wouldn't allow them to do what we are asking them to do. If we task them with walking up the stairs and said, well, then the stairs get smaller for you because you have less muscle, or the steps get smaller. How does that translate to everyday life? They are not going to be any better off, and the measure is just going to show that they are more similar to a population that they're similar to. But here we're testing something where we get a very, I think, very fair to everyday life measure of what are your capabilities. But definitely, there are so many factors we can change and say, okay, but what if? And I think the other studies finding no differences between two populations who are clearly different at baseline, and in our case at PhD, they might not reflect what I believe, or what I believe that the supervisors see in their clinic, that we have a population of people who are more, who get fatigued earlier.
Yeah, and your older CP population, so was that the group that reacted, that dropped the most in their course, right?
Yeah.
Yeah. Do you think that was that because their first stage was relatively
double as hard compared to their maximal baseline capabilities?
Because it was based on body weight.
Because it was based on body weight.
So was it surprising to you? I mean, maybe that's the reason that they started
more relative work to begin with.
Yeah.
Yes. But the magnitude of difference between two groups is huge.
Yeah.
Like the immediate drop in force cannot all be due to them having a harder first stage, because it was still not that hard. It was 12% versus 6% of your maximal strength when doing an unfair comparison between static Newton meters and dynamic watts.
Yeah.
So they're at a disadvantage for sure, but they're also at a disadvantage when walking, when climbing stairs, when standing up, walking around stuff. But it's I don't know if it's the holy grail of exercise testing. I think it's more fair than saying, okay, we base it on capabilities. Basing it on lean body mass could be interesting.
Yeah, but I mean, we touched upon this yesterday when we were talking, right? That it's how do you compare? Because the relative intensity will be different.
Yeah.
Okay. And then one more detail, like the cadence that they bike at, 40 RPM.
Minimum, yes, but that was for the cardiopulmonary test.
Okay, so when they bike on with this, they can have.
We said choose a cadence and maintain it between 55 and 80.
Oh.
We could have been strict and said, okay, here's a metronome, but that would just not allow some of our participants to pedal, or it would lead a disadvantage to everyone typically developed, because we know they would prefer 70 or 80.
Yeah.
I mean, Pogacar goes 100 per minute, but for the cardiopulmonary evaluation, we used 40 as a cutoff, simply because of problems in turning the pedals, and because the watts they push are not important to us, but the measurement of oxygen consumption is.
One more question about that testing, the bike.
Yeah.
Do you think it would be of interest to use any other kind of measure of fatigue, like rated perceived exertion, or
Yes.
metabolic test, or lactate, or whatever? Did you consider that?
Yes. And I don't know why I ended up not using RPE, because everyone else does. No, but all the two studies I mentioned from the same place used RPE. I think my idea was that I'm assuming, and I have a measure of EMG. I have a measure that could indicate how much are you contracting the muscle during each stage compared to your maximum, which we have issues with normalization when the EMG electrodes have been on for long, because they might get hurt. But it's a very strong objective measure, where if I can get to the next couple of slides, I cannot. Is it because I'm unable to use a computer? It is. Let's see how far we have to go. Too many slides, I'm sorry about that. No, not this. Here, we have the EMG root mean square in percentage of the EMG max as a sort of proxy of how much work do you have to put in to pedal through every stroke. And we quickly see that our young participants, typically developed participants, they are on a holiday for all the first couple of stages, and that our older adults with cerebral palsy start off 30–40% of their maximal contractile volume during the first stage, second, third, increasing to really pushing it in the end. Also have a fun outline at Rackauskaite, someone really pushing it. But I think that as a proxy for effort.
Yeah. Yeah.
Last 4 would be easy.
4 would be easy.
It would be so.
Do you mind taking up slide 22? That's your the figure from your review.
I think I have it here at the end as well. If we can use this one.
Yeah, we can use this. And when I looked at this, do you think that should I read this as factors contributing to decline in gait function with aging, or things that are affected in people with cerebral palsy?
I see what you mean, because we are not linking everything to mobility per se. The idea with the figure was to showcase both what is worsened, what can we see is in an observational study worsened compared to the typically developed population, but also with the arrows say, is it accelerated compared to typical aging? So no, you probably cannot say these are effects that we know from other studies might affect mobility, but we're not measuring if they affect mobility in this figure.
And the lower VO2 max, will you put a question mark?
Yes, I don't have any studies evaluating time, so I couldn't put a. We can see that it's lower in a lot of studies, but the longitudinal studies.
Do you believe it dropped?
What we we've seen, I think it depends on how you measure. Because surely our lowest scores were also those who had issues pedaling. So is this fair then? Are we able to push the heart rate, everything to the same extent on a bike compared to you and I? It might drop, but I don't see why it should. Well, yeah, if you're less mobile and therefore because of that, I mean, they still have to walk half the steps to expend the same energy. So
yeah, let's see. You have to do your forever study.
The forever study would be so nice.
Yeah.
They would get so good at electrical stimulation.
And then if we kind of home in now on your box to the left, there also the biggest box.
Yeah.
Nice, a lot of muscle factors. And one thing there, what do you mean by the muscle tendon gene pool?
It is.
Why? It's a question mark.
Yeah. At the time of writing, I was reading some very nerdy but super interesting studies coming out of the Copenhagen University with Jessica Pingel. And from, his name starts with an S and has a million letters I cannot remember. But they indicated that there might be some differences in the build-up of the muscles and tendons, similar to what you presented yesterday, with some sort of genetic difference in the markup of the muscle tendon gene pool, or in the expression thereof. And I put it because we mentioned it within the paragraph on neuromuscular alterations or something like that. And because I found it interesting. It sounded so cool to have an understanding of what expressions could be precursors of changes downstream.
Yeah. I'm thinking like some of the stuff that I showed you yesterday, it's also kind of the activity of the genes.
Yeah.
That's different. The muscle in cerebral palsy looks like it's making other things than what TD muscle. And some of that stuff could be related to aging. I was also thinking about the kind of quality of the muscle. As you talk about increased fat content that you know. You talk about maybe also the extracellular matrix that might be stiffer and so on. There might be more, and how this affects the muscle per se. You don't talk so much about other things like at the microscopic level, which is not the area of the thesis. But there was two things that I was thinking we should talk a little bit. One is you talk about the sarcomeres in series. Theory, but you don't talk about sarcomeres in parallel. And when we talk about strength and force and power, maybe power could be influenced by sarcomeres in series. But force is typically a cross-sectional thing. How do you think about that now when we stand here?
We have an indirect measure of in parallel through muscle size. I would argue that you don't get big muscles if there's nothing in parallel. We don't have any measures of power. So yes, you're right. You could argue for talking more about sarcomeres in parallel than in series. It again came down to what literature do I have on adults? Which is, as we saw in the beginning, minuscule compared to most children. And because I thought, well, parallel equals size, so we got it covered in sarcopenic tendencies. And I then figured it would be more interesting to talk about the lengthening of the sarcomere, because affects the contraction velocity, but also, I would guess, the maximal force. If you have a constantly stretched fragment, it doesn't overlap properly between mass and active. But yes, you could talk about parallel.
Yeah. You could. And then maybe the final thing that I want to talk a little bit about is when you assess cardiopulmonary function, you talk about basically oxygen uptake, right? That's in the signal. And it's uptake then means uptake by the muscle. Do you know anything about the number of, let's say, small blood vessels in CP muscle?
I do not. You hinted towards it yesterday that there are differences in mitochondria and
The amount of mitochondria, but also blood vessels.
but that must be linked. Or what?
Could be linked. But and then the other question, you say here that your old CP population shows similarities to a very, very aged population that has previously been assessed in the lab. What do you think happens with aging and the number of blood vessels in the muscle, the small capillaries?
I would guess that similar to nerves, they start, well, one blood vessel starts to cover a larger proportion of the muscle, and like you see with nerves, dying or
There is something, a process called capillary rarefaction. You have fewer and fewer capillaries as you age. When we look at teenagers with CP, we also see fewer capillaries. And having few capillaries, if you're old, that predisposes you to less of an effect if you're in an intervention study, compared if you have more. So it seems to be very important, the number of blood vessels you have in the muscle. And if you like histology and muscle composition and CP, and you look at new studies that just came out last year from Belgium with Professor Lucas, they've looked at very, very, very young kids with CP, starting from 2 years of age. What do you think is the only thing that is different in those muscles compared to 3D?
I read the abstract.
If we talk about blood vessels for 5 minutes,
Yeah.
What do you think?
What might it be?
Yeah.
But it comes back to the talk we also had yesterday about accelerated aging or neurological differences, which again, yeah, if we could pile onto this protocol and add biopsies at blood measures, it would be so interesting to say what happens over time.
Yeah.
Yeah. When you spoke about it yesterday, I was like, that is interesting to talk about accelerated aging already at birth or already super early.
If we think that having few blood vessels in the muscle is a sign that we typically associate with aging, we see it in 2-year-olds. Feels like we're, our interventions should probably start earlier.
Pretty early, yeah.
Nice. Final question.
Yes.
We haven't talked about power of your studies. In your protocol paper, your groups are almost twice as large.
Yep.
And you end up with less, which is typically the situation when you work with people with cerebral palsy. How do you think that affects the results that we looked at today?
I started speculating a little bit during my presentation on the variation within groups. And obviously we don't have the resolution to investigate the finer differences between the younger adults with cerebral palsy and the typically developed peers. I think that's where we might see some differences that are not now statistically significant. We've also chosen to go with the most conservative statistical approaches due to the sample sizes being so small, and rather wanting to be convincing in the differences we see, and then leave it up to future studies to investigate. possible tendencies, which I have a hard time saying because I know there are a couple of method specialists up here that will say, "Oh, you don't talk about tendencies; it's not significant." It is frustrating to have the idea of a study that would be powered really well for investigating each of all of these measures, but does not allow us to also make correlations. I did one in the discussion. I don't think it merits being attached to a paper, but it's interesting and it might guide future studies. We could also just split the study up into a million small studies, and every reviewer would be like, "Okay, it's powered enough." But I don't think we have to power in a lot of the measures. However, in those where we see differences, if we see differences, they might be due to people we have included, or it might be actual differences that due to the the accuracy of our measures might possibly be there. But I knew it was going to, I knew it would be there, the talk about power. It is like that. It would be nice to have more. We can show quite a lot with a small population. I think our matching is very fair. We have a lot of measures set up to argue that our matching is good.
Yeah, and I like it, that you're aware, but the study merits publication, I think.
Why?
Because in the field of cerebral palsy, vision and the battery of testing that you put through, if you haven't worked with people with CD, you don't understand how, it's a very good field. Yeah, the captain tenant there. Just wanted to say that, and I wrote it also in my review to or the thesis, that you might not understand that it's a very hot topic. It's a very hot topic. And if you continue, I think some people feel I need to try something else. Maybe you should stick to this. CV and aging, I think that's key. All right, thank you.
A little bit of this.
My one. Perfect.
Okay, so first of all, I would like to thank the supervisor for the invitation, and thank you, Anders, as well for the manuscript. I read the manuscript is I found it very nice and very clear as well, especially for non-experts of the disease. But it was very nice to have this presentation also here. I also enjoyed the literature review. At the beginning, I thought it was very descriptive, and I was waiting for, okay, that's what's the influence of your work. But when I started reading your review, actually, I really liked the blue notes that you added. That was very, very important to highlight why we need more studies with aging CP and all that stuff. So that was a really good idea to put that into the manuscript. It's not very usual about that, but it's really, I would like to highlight. So now we switch on the question part. I have a lot of questions, but I choose some of them. And again, it's a discussion. The goal is really, you did a really great job, and the goal is more to discuss, to challenge sometimes as well, but hopefully in a nice way. I will start with the beginning with your article review. So you said, we aim to predominantly studies after 2012. And the question is why? I don't remember what happened in 2012, except maybe the Olympic Games in London. But why did you split? Did you choose to only studies after?
I think it's from 2012, there was a large review on what happens in cerebral palsy amongst adults. So we figured, well, if there's any merit to publishing a new review, nobody's going to want to read what's already been reviewed. And simply, well, yeah, then let's not look at what happened before. And I said that, and then I included the studies by the Swedish or Norwegian large-scale studies anyway, but mostly as descriptive parts. So the idea was to include stuff that had not been condensed into a review before.
Well, just because while reading, I was thinking, you think that all papers are not as good as new papers?
Yes, that new is always.
You decided to include participants with bilateral spastic specifically, and I think that, as you said, it's to have more homogeneity in your groups. I think it's a good idea. But now I also want to discuss other details about the inclusion criteria. Earlier about the control group, but now it's more on the CP group. For example, inclusion criteria included ability to work for 6 minutes continuously. What do you think? Is this a bias to add this into the?
Yes, but they were allowed to walk with a walker if they needed. Our protocol simply required so much mobility that including someone who could not complete the first task and help us understand our first objective would be counterproductive. It might be a fair inclusion, but you're not going from GMF to CS level 2 and until 4 in that short span without something extraordinary happening. So the idea was, well, if the participants should be able to complete the protocol, they would have to be able to live up to a minimum of mobility without any measure of how far they should walk. They could have walked 2 meters.
I understand the choice, and I think it's completely fair. I would like to add, if possible, flowcharts in your studies.
Yeah.
Because by doing that, we will know, because I was a bias of selection, by doing that. But if you tell that at the beginning, I was able to include possibly 80 people, and the 80 people, only 60 are able to walk 6 minutes. So now 20 agreed to participate in the study. We have an idea of this bias of selection and how many people are not able to walk while they are in the stage 1 and 2, that 80. So I think that would be something interesting for the whole picture of the population. But I understand. Also, so now it's the next article, article 3, but it's linked, so that's why I put that together. So you said that in the analysis, you have participants that were not able to from 0 to 5 meters, so you remove them from the analysis because possibly they would screwing. And I was thinking, why is this an issue? I mean, a 0 is a number, so you could have a 0 in the data.
Yes, and if we had more participants, I would do a sub-analysis. But adding 3 participants, I think it was, who, due to operations of the ankle, could simply not move it, had no range of motion, would just lead to what I think would be an artificial difference. Because including those who could would be a fair comparison to the younger peers, but including those who couldn't would be a fair comparison to the matched controls. And it was a question of what comparison is more important to us. And putting it in there, the reader can choose to say, okay, it's already significantly different between the typically developed population and the population with cerebral palsy. but it's not different amongst those who are able to, who have range of motion between the young and older groups. So that was sort of the logic behind that. And then putting it in text, reader who really spends more time than the average on reading an article might come to the conclusion that, okay, there can be differences and there is a large heterogeneity in the force produced.
You understand, but I think significance is one thing, but after you can have a 5% significant difference and a 50% significant difference, and the story is not the same. And I'm just thinking that maybe by doing that, they need to work, they, of course, if not, I don't show the data. I mean, at the end, you are very optimistic with the population. So that's maybe something also to keep in mind for the analysis and yes, for the conclusion, because at the end, in terms of what they are able to do, the mean would do worse. But on the other way, you use the worst name. When possible. So that was maybe you were to balance a little bit that. But
He's got the least pessimistic estimate that we can put.
Also, if I continue with the methodology, the groups, they were matched one by one between CP and TD, but not between young and old. Which means that male and female, the ratio is different between the young and old. And as you know, there are sex influences in your outcome. So how do you deal with that? Can you conclude on the aging effect?
We can talk about, what can we talk about? We can talk about differences for sure between the matched populations. Well, you're right. When we deal with men and female within the same group, and if there's not a large weight difference between men and female, there might be some differences due to the effect of testosterone. We normalized all data to weight. That's one way of trying to minimize the effect. But if I've added the absolute values as well, you'll see that there are sort of two groups in the older adults with cerebral palsy, and that is gender based.
So that's the idea of normalization. Can we do something else in your analysis? If you look at your four groups, can you do something to counteract maybe this a little bit?
I mean, we could add gender as a factor, but with 30 people total, adding gender would, I mean, then we'd be testing 3 people in the older group and 6 people in total and 2 in the younger group. It's simply not fair, I think, and we have the tables that show the gender of each participant, and we have the numbers allowing you to say, all right, I can see all the data presented. I know who's a female, who's a male. I can follow them in all measures, and so I can do a fair comparison if I so want to. We don't have the power to start stratifying the statistical. It's so much fun to follow number 2.
It's linked to this one. The muscle consequences of CP look quite similar to activity, except the functions, the framework, the coordination issues, but you could go to max in working test. So in your results, can you tell us if the maladaptation you observe in CP, they are driven by the reduced physical activity or the disease?
I can only give the wrong answer with Ferdinand sitting there and have just discussed it. As we spoke about, there's definitely a difference at baseline. If we accept that there might be an accelerated aging, then it's a question of what comes before what. Are you reducing your physical activity because every meter you walk costs double as much? Or is the cost of walking doubled because you reduce your physical activity? If we look at the introduction where I talked about how much physiotherapist therapy do you see, then the children are seen by physiotherapists 1,000,000 times more than any typically developed child would without injuries. But so at least everyone with cerebral palsy will know that they have to move. And I'm sure they're moving as much as they feasibly can without it affecting everyday life. I mean, if walking is a conscious act, again, then it's strategic. You're training your mental capacities, you're training your physical capacities. So walking less per day. But so far, our results show no difference in VO2 but other results do. Then what comes first?
I think this is a very important question. If I was working on this disease, if I was a physician working with CP patient, I would like to know this question because this answer because I would be able after to use the literature on sedentarity and activity because it would be the same. The reduced activity and therefore we see all of this maladaptation, or it is specific also to. And I think that would be maybe something to push further, and maybe with some analysis. For example, you talk about covariance with sex. Again, maybe with our studies sample size, but at least in terms of methodology for the future, maybe that might be also something to add and to know which part is an activity, which part is the disease. And I would have the same question for aging.
Yeah.
So with age, can you tell us the impairments with age are all driven by aging or by the disease itself? And that's why I asked you before, like the absence of matching between young and old makes it difficult to answer that question. But if it was the case, you would be able, with a good sample size, to answer that question. With normal aging, and aging with CP, it's a slope is different. And if we talk about slopes, in your analysis, if you look at interaction effect, you can actually answer that question.
Yeah.
So actually, you could do it. And that may be one thing, depending on stage of the manuscript, but you could add. You will not talking that much about the interaction effect.
It's me being very conservative. I try to present a correlation matrix in the discussion, but as I also wrote there, we don't have the power to really say this is a true estimation of reality. But possibly, if we could repeat the study multiple times, we would also get the same answer without having to match the groups. And we would see if there is maybe an accelerated aging after the age of 30 or 40, 50, our group is 4-year-old, or if aging declines at a constant rate. It might be that it's a very linear relationship, which would again help the argument that you really have to take care of children and then they'll have a better life after, which is the general sentiment I believe that the doctors here will also argue.
But I think you could if you're saying, okay, you have sample size, we know it's the dish for you is good enough. This volume. Okay, there is some merit in I want to publish. Then you can't always say I tell you, but I don't tell you. So
yeah,
at some point, trust your data. Obviously, with some limitation, and you wrote it in a nice way as well, you're not avoiding your limitation in the discussion as well. So you show your maturity in terms of science, but after you also want to try to have the answer. So I think that much is Jason, but push your data as much as you can. Obviously, you can't, but guess what? Also, in your analysis, it's always CP all. And in your analysis, they are based on comparison with this group and almost only this group. For example, I would be interested to know for you to pick and strength data if there is a significant difference between the healthy, young, and old. That would be an indication as well of your power, because we know what should happen with normal aging, because we have a huge amount of data in the discussion. If you replicate the results, actually that gives you strength to say, actually, I might have enough cover.
Yep. It could be added. We are at work limits and at limits regarding what our objective is. The typically developed population is mostly there to showcase what would you expect as the difference between a young and slightly older, because we're not talking about anyone who's really old. What would be, if we're talking that avenue, it would be super interesting to steal all Eric's and Matilda's data that I showcase some of and use that in the analysis, because that gives us 20 years old, 40 years old, and 80 years old to really show, yeah, our data and what we measured in this lab looks like what we would expect. Yes, it could definitely be added.
In your graph, you have lots of trends.
Yep.
But in your studies, you have multiple types of trends. Different velocity, different contraction modes, which is really nice. And at the same time, it can make it difficult. So if we look at that in detail, between CP and health and quality control of the whole group, if it's consistent and straightforward, we have significant difference everywhere. Between CP, old, and young, for every muscle group, because you also have three muscle groups with different types of testing, the results are significant or not, depending on the contraction mode, on the speed, and it is not consistent across muscle groups.
That is quite fun, because what factors could answer that? I think to some degree the differences in what surgeries you get as a child now, or as a child 20 years ago, or 40 years ago, there's a large difference. We don't see multi-level surgery to the same extent amongst our older adults with cerebral palsy as we do now, which is also possibly, without being certain, why we see that it's only among the older adults that there is no production of plant-like flexibles, for example. So I think in some cases there are range of motion differences. We could only test them in the range of motion they accepted, which means that, for example, for some of the dynamic measures, they might have had to produce force within a very short range, meaning that the stretched sarcomeres, if they are stretched, which it seems they are, would render them at a disadvantage, because power sarcomere in tandem has a great effect on that. Whereas for a static contraction, they would have all the time in the world to contract. And I think what would be interesting to add would be measures of RFD, rate of force development, to say, okay, we realize that dynamically there might be different issues than what we see isometrically, but we can test some of these using a measure of rate of force development, because it tests some of the same things, but removing coordination.
Yeah. You can add again another measurement of the
Exactly.
measurements.
Yeah.
But I think what I would suggest first maybe would be to discuss a little bit more.
Why that is.
Yes, why you have differences. Exactly what you said. Even if obviously you will have some speculation a little bit to be a discussion, but maybe I missed it, but in the papers, in the discussion, I'm not sure I really saw this type of discussion. So if you did it, obviously you have a goal, and so that probably to enter into this complexity.
Yeah.
So you have to go to explain that.
If I could find a journal that accepted massive manuscripts, I have something for every single part of our results. Because, for example, as you're saying, it's super interesting to discuss all these things. But there are so many facets to it. I put in co-activation, which is definitely worse when you have dynamic movements compared to symmetric movements, which could also be a factor on top of multi-level surgery and on top of sarcomeres in serious or parallel. There are so many things, and I think the articles in the thesis are never going to be published in that link because no journal will accept it.
Okay. I understand that now it's really something to consider as a strategy for publication. So should you do different papers or not? But you did the effort, patient did the effort of doing 3 different exercises for 3 different muscle groups. Maybe if there is a reason for you to add that, and try to find a way to add it into discuss it.
Yeah. No, but it's, yeah.
Now we have to move on to view 2. As you said, some participants, 2 participants, achieved a higher view to peak while working during the 6-minute volume than on the max time. This will concern as to the validity of the if it was possible to restart the study, or if you do your follow-up every 5 years, how would you do to follow this to make sure that it is max?
See, if it's in 5 years we start, then the Swedes might have made a frame run test that can assess you to max. That would be a super place to start, because it seems that the constraints in practice and so on are definitely limiting the ability to obtain a valid measure of V2P.
Okay, so let's say you do a frame.
Yeah.
Max step.
Yeah.
So your participants, your patient stops at the level of V2. Is it V2 peak? Or how can you get V2?
We put in V2 peak because some participants did not have an RER that was high enough, and some participants did not have a lactate response that was high enough. It's a way of safeguarding ourselves, because if it's a V2 max, there are some criteria that we need to fulfill. We did not in everyone, and so we would, rather than exclude some, just say this is a V2 peak. Here are the reasons why it wasn't V2 max. I don't know what single exercise would be good enough to measure V2 max. We could also consider a hand pipe, but we know that the measure is going to be maybe 70% of the real V2 max. Or we could do walking, but walking on a treadmill sucks, according to my participants. So
I think as physiologists we can agree that the criteria, as you said, are not that good. For patients, for athletes, for anyone. But one way to circumvent this issue, it would be to do after the max test at the next stage.
Like a 100%. Yes.
105%.
Yeah.
So it's an idea from Hureau, and it's quite well accepted that it might be the best way. And at the next stage, you shouldn't be able to reach higher level. If you reach higher level, that means it was not your peak. If it's similar, that means it's really good max. So just if at some point you feel that huge max is really a big deal, you really do max. That might be an option.
It's also great fun to do.
And you could do it with the free running, with the bike, with whatever you want. It's just the methodology, but you can do it with any woman. In your article number 4, you have the max. Again, I get about the max test. I think you should have the power output at the end of the max test stage, because you put the stage 6, stage 5, but I'm not sure what it means because they don't start at the same power.
No.
So at the end, you start on finishing at stage 6 or 9, but it doesn't really matter because it could be the same power at the end, or absolutely not the same power. You know what I mean?
Yep.
Power start, and also the increment is not the same.
The increment is the same.
It's the same increment.
Based on body weight.
Yes.
So
it's not the same.
if you want, but relative.
Yeah.
But we had to normalize to something, and ended up being body weight. And if you really wanted to, well, yes, we could say participant 7 weighs 52 kilos, and at stage 4 is at 1.5 watts per kilo. But yes, it would make sense. It was a way to simplify the results a bit and just say, well, if we have a similar evolution based on body weight per stage, then a number is easier to calculate than, say, 120 watts. And the graph would look weird if we do absolute measures on a test that's based on body weight. This is very simple. It comes back to being super simple.
I mean, it's just a small
Yeah.
suggestion, but why maybe I leave that in text or
I-
somewhere that someone might want to know
Yes.
the difference in power at the end. And maybe commenting to that is because you have a max test of different stages and you stop and you measure fatigue, do you have stages in common? For example, it would be last stage of CP is the same that second stage of healthy control. So to have in the same test, you would have at the same absolute intensity and at the same relative intensity. That might be also a nice way to show the difference in fatigue. Because in terms of fatigability with a question mark here, at sometimes you're pushing, it's the same fatigue at that figure. So it's the same fatigability. But no, it's not, because it's faster. And also for lower intensity. So in that way, maybe one figure in the nice way. Okay, relative intensity, absolute intensity, and so on.
It's this test is so much easier to read about once you have seen and tried it yourself. I realized that when I came to the lab because I had read about the KIF test or what the intermittent fatigue test or a fatigability test like the one used here. And it didn't make that much sense in my head. But seeing the bike, testing it, it makes a lot more sense. And it's difficult to convey exactly how to test this if you're not used to seeing it. And I realized that. And I obviously haven't found the perfect way of doing it. But it's any feedback on how to really express what we're testing at what point and how they are comparable is very nice.
Again, it's a good discussion. And at the end of today, we'll keep what you think relevant and what is not relevant. You put that on the side, and it's
The best test.
It is, of course, the best test in the world.
So I will now switch on to your general discussion, and you said correlations indicates an agreement with Salam with energy expenditure being more important in determining performance. What is your interpretation of that? Okay.
So the cost of walking, which must be influenced by how you walk, and well, it's an attempt to link the studies by Gill and Gillett, who find that your cost of walking is highly associated with how you walk in the Gill study of 2,000 kids. They find that if you are walking similarly for every step you take, then you are better, you're more functional in walking. And so your cost of walking must be more predictable, or a stronger predictor of your performance in a 6-minute walk test than your V2P. It's a way of trying to say, maybe we should focus on functional mobility before we focus on cardiopulmonary measures if we want to improve mobility amongst athletes with cerebral palsy. But again, very defensive, because we see a correlation, but we have no test of causation.
So I guess most of your participants, they don't contribute maximum the 6 and 12 tests. So it's not like that surprising that there is not a very huge correlation between your max and the test.
No, but you might still think that 6 minutes is enough to stress the cardiac system, the aerobic system more so than the anaerobic system. So it might be a lot. Well, you might come to the conclusion that, well, then it must be aerobic effort. Therefore, it must be linked to your aerobic performance.
You have your data to support this. Like if you look at your percentage of your max and the system test, you remember?
Yeah, it's 80% in older adults and 50% amongst everyone.
In average or max?
During the 6-minute walk test, they are at 80% of their peak oxygen consumption, compared to 50% amongst the rest.
Because if you look at the determinants of endurance performance, you have the 2 max, you have the concept of locomotion, working here, and also like attrition. So there are 3 main components. So on one way, if the correlation is not perfect or huge in any of one of the 3 parameters, it's right?
Yeah.
And maybe a last question about your perspectives. You're talking about tandem biking.
Yep.
And I found it was a very interesting idea, but you don't put the idea up to research. You say, okay, you could then
Yeah.
maybe it would be good. Okay, but with your background or with your background, if you want to convince at least working with CP, how would you do, what kind of research should we do?
I have played with the idea of looking at muscle coordination while biking, see if we can improve it. With regards to the tandem biking, it was more in an effort to include people with CP within communities that they are typically barred from due to not being able to keep up with a cycling club. If we put them with, we pair people who can steer the bike, then in the back we could have someone possibly dyskinetic, someone ataxic, or someone spastic, still being part of the social aspect of a sports club, and possibly stay within that sports club due to it being a nice experience, instead of it being the physiotherapist who they. But then again, if we were to test them before and after, which we would, that would be the perfect case. we could put them on a normal indoor exercise bike because it would have the same stability. So we would run into the issue of we train what we test, but we would still be able to test exactly what we want on an indoor bike and then have people train outdoors on a tandem bike. But yeah, it was an idea.
Okay, thank you for the discussion and congratulations for your work. It's for good.
Yes, now we've softened you up for the audience. If there's any question from the audience. We've been asking questions for 2 hours. We took your questions. So then we leave the word to the supervision team. We're going to start with the Professeur meeting.
I would like to start by thanking Tamara and Maître. I'm not really actually from the supervisory team. I'm not totally on the focus on my kind of in between. Wasn't the first time I'm invited in the committee, so I'm not sure what I'm supposed to do. I'm not going to comment. So I decided to go for some questions. Being here for first, so I cannot just say a few words, so I have to very good. I'm quite impressed actually by the quality of the answers so far. Seriously. The jury, I'm not looking forward to doing this thing. But okay, no.
You can get some new batches.
I don't think but yeah, but maybe they have a different opinion. We'll see that. And I don't want to ask too many questions. Already got them and I'm not going to delay my lunch. Okay, so just a couple of questions. Some of them have been actually already discussed, so go on by but not all of them. So first, I want to go back to speed and energy cost of walking. So if I understood correctly, huge variability between CP in terms of preferred speed when expressed in percentage VF. And this is due to large variability in terms of energy cost of walking, so how much energy cost to walk, more than VF well. And my question is, I don't remember if you or we have done this analysis. Another way to express relative intensity is to express in percentage VT1 or VT1. We've done this type of analysis, and if not, why? And is something we could solve.
We could possibly have it for some participants, but not all. In some of our VH tests or VO2 peak tests, we simply do not have a discernible VT1. I
just have to check that. We tried that.
I looked at it. I asked my good friend Jan, who's pretty good at finding that, and none of us could agree on where it would be. It was simply the VO2 kinetics were weird compared to what we saw in typically developed adults, and some of the tests were quite short, so we did not see a gradual increase.
What is it?
Increment might have been too high. The act of cycling rather than the intensity of cycling might have been enough to really provoke the cardiac system. I don't have the answer, but the data are not looking typical. And I've seen quite a lot of VH tests, and I've conducted quite a lot of them, and some of our results are simply not looking like you would typically see. it would be super nice, and because Eric expresses it nicely like that, but I don't think it's possible for subpopulation. But then is it then maybe it's interesting.
You agree that if we had to pick up two main factors explaining the left of. Well, if I had to do that, I would probably choose walking and motivation. I mean, there are. Would you agree with that? At least in the first few.
Yes, I think so. The cost of walking. I mean, simply consider it. Whenever you walk, double the cost. Every single step costs you double. It must be accurate. Whenever you do anything, any small act, it must be fatiguing, and it would stop me from walking. I mean, if I've trained and had the choice between the elevator and the stairs, then most of my colleagues can say, okay, we actually take the elevator from time to time. I think that's
the one important factor. The one going for activation based on.
Yeah, and that's part of why I think our test based on weight, linking weight to mobility, it's very relevant for the voluntary activation question, because if we just compare what you can do, then we would be like the other tests and test your capabilities and the evolution of fatigue from them. But if we include the weight and voluntary activation, then we already have a deficit at baseline, which again possibly affects your cost of walking, because you might have to activate more muscle fibers or send a stronger signal every time you walk to activate similar amount of muscle, if we can scale it like that.
Okay, that's good because yeah. We agree that those are important factors. What could you do? I know you already discussed that in the previous questions, but voluntary activation, proper walking. So what else? So you're talking about boxing to improve on activation. But what else could you do to improve both and voluntary activation?
If we talk about training interventions or interventions in some way, I would say anything explosive, anything when you're standing up, or to some degree
For recreation.
for voluntary activation, but also for balance, which we know is very linked to your cost walking and your gait.
Yeah,
But
it's voluntary recreation and proper walking. So tell me what you would, what else could be done to improve those factors. Maybe what I have in mind, and maybe this is completely naive or stupid. For voluntary activation, if you want to improve the neural drive, what is usually recommended in non-clinical populations to very high load. So what would that be doable in TP population time?
they are not. They are. There is no one saying no to training, and you can push people, and they'll be happily pushed. At least what I find. My idea with power training would be to have a similar full-on activation of muscles. But yeah, heavy strength training would probably also be possible, but would also require quite a lot of changes in the way you do exercises.
Or maybe there is just no way to practice because this is the natural history of the disease.
But there's something.
And for cost of walking, there are things that people actually technique of walking. We are just mentioning the variability in steps, taking steps, which doesn't mean that if you reduce the variability, you will improve your reduce cost of walking, but still. An idea is to try to do some biomechanical measurements we do in this. Try to improve maybe this is actually done and it's actually a very, again, very nice comment. But we won't talk too much about that.
No. If you look to your right, then you see someone who does exactly that. We see that training what you want to improve also works for adults or children with cerebral palsy. And at least in the Amsterdam laboratory, they use what they call a grail, where it's an instrumented treadmill where you have an immersive VR experience, sort of. And they try to provoke you to walk better and improve your balance using biomechanics and feedback.
And does it work in some part of walking?
That's for balance and a walking pattern, but not constant walking. It's really difficult to improve. Since you have abnormal motion.
So, if I took probably what you said, and I think we just believe that. Saying that they feel that it's part of the 6-minute walking test, and we expect, correct me if I'm wrong, must explain part of the general fatigue that they feel. I am to agree, this is something I try to do. In what I said, part of the explanation, feeling a greater fatigue, but at the same time, could be, but you said like it must be a reason. Why is the evidence? Why do you feel that it plays a role in explaining the greater fatigue?
I don't have the evidence. I don't have anything saying the more constant walking, the more fatigued you feel in day-to-day life. And I would think that there are a lot of factors influencing that as well. It could be that less mitochondria in the muscles require less cardiac output from the heart, meaning that just your aerobic capacity does not predict how fatigued you get from walking a set distance. Or that, I don't know, I don't have the evidence to say it, but it seems logical to me that
it makes sense.
if you have confidence.
Yeah.
No,
I agree. I feel I try to with this idea that fatigability is when fatigue or in your case greater because could explain fatigue, but we don't have any zero reason.
Yeah.
Quick questions. In the fatigability test, in the problems with CP, in the first 2 stages, and then there is
Yes.
how does it work? And there is also a huge variability. So
There's massive variability.
a mean way to ask the question would be a really
You could definitely argue that there might be some familiarization to getting the twitch where you don't tense up before. It's possible. We haven't measured the hamstring.
You should see the baseline.
But I don't know what else would cause this. Well, yes, you could have some movement of the electrode during the dynamic task, which would move the electrode. If they're sweating, the electrode can move around. So there's a large variability. We see, I'm certain that we stimulated at maximum because we went far above the plateau.
There is variability. I mean, the variability in this test on the bike is higher than the same thing on the chair. We know that, but for me, it's not a reason to not do it on the body because it's more logical. I think, as you said, that we are protein, there is almost an increase in big reach at stage. Okay, maybe my last one. The question already asked by Gija. So, at exhaustion, did you expect that peak reach will be actually higher in the older adults in CP than and then you have this discussion with accelerated aging with Ferdinand. And so I would like you to further comment on that. Because to me this is actually, from what I've heard, and if I understood correctly, this is not surprising at all. If you make in any study, we find the reason why you should expect actually a lower fatigability at exhaustion and greater fatigability at the in this group.
If we have a fiber change, typographical fiber change shift from type 2 to type 1, which we have seen amongst young adults with cerebral palsy, then that might to some degree explain why a less fatigable muscle or in a muscle that's maybe predominantly less fatigable, you'll see a decline and not be able to continue in the global voluntary maximal contractions. But you might see that you cannot fatigue the muscle because it is simply a very highly oxidative muscle.
On the step explanation for I agree. Yeah. But why don't you have they are more fatigue resistant, so you can explain the lower fatigability for a given work. But what can those fibers to get a greater fatigability at exhaustion? Yes, no.
What are we
Glycolytic. Maybe less glycolytic than we can decrease to the same extent.
Yeah, but it's again,
Is that the determinants?
if I have a fiber type composition, we could start talking about this, but it's speculation based on earlier studies or comparison.
But no, it's not. You think it's a fair?
It is fair.
Also here, once again, to the defense, and thank you again, everyone.
I went all the way to me. That's it all the way to. Now, I'm sorry, just picked up saying that that's a part of the supervision is an independent actor. Start with one.
I'll just come and pick the microphone up, and I would like to join you on those, at the front. Now we're going from the stage from the discussions to our description of your PhD journey. I was part of the team, and I've been so happy to be part of the team in these past so my role is not to critique you. I have had years of time to ask you questions and have discussions with you. It's more my role to put you in the sunlight, as we would say in Dutch, and maybe convince the jury a little bit more. I don't think it's necessary because I think you did so well today. I can say that already. I've been lucky to be part of this journey. I've been asked by Thomas. I went back in my emails, and Thomas and Bruno, they conceived this project, finding a very important clinical question about adults with sports science expertise from Thomas to work together and try and understand a little bit better the clinical problems that these people have.
And I'm a pediatric rehabilitation physician and have some implementing with these patients. So, yeah. We were looking for candidates, and we got this really charming letter from you to apply for the function. Danish sports scientist with already some research experience, and you applied, and it was a really interesting letter. And I read it back just a few days ago, and I realized I hadn't made enough use of your ability to speak Dutch, which was in your CV. Because you were a ski instructor and I instructed Dutch students, and I don't think we ever spoke Dutch, but now, from now on, I will give it a try. Not right now.
No, please.
And another really nice thing that I saw was that you ended your letter with thank you for your time. And it really struck me because now I read that again, and I think it says so much about your your respect for other people's time, and not just respect for your supervisors, but respect for people that you work with all around. And I think we've also been able to hear this morning how you described working with patients, and I really admire you as a sports scientist, not as a clinician, work together with patients and really try to understand their problems and study them with a very complex research battery, but also really have an eye for the people behind the problem. And I think with this small sentence, thank you for your time, at the end of your letter, it was already foreshadowing something about your personality, which I think is really, really important in this field. I really have to be a little bit brief, so I will try. I think it has been really wonderful to work in such an international project, and the project started the recruitment started in May 2021, the project started later that year, and that was still in the middle of COVID time. And I was reflecting on that, and I think on the one hand, our world had become very small, we were in our rooms and behind our screens, but on the other hand, it didn't matter if at the other end of your screen it was somebody from the other end. So on the other hand, maybe it made our world a little bit bigger, because collaborating with people abroad was just as easy as collaborating with people working 2 streets further on, because you were all communicating in the same way. So that has been special, and I think you have really made a very nice combination of Northern European, Scandinavian preference for minimalistic design, combining it with a really French way of discussing, I think, with a very philosophical, intelligent way, not afraid to use a lot of words to say exactly what you want to say. I think it's a really unique combination that you have in you, but also really benefited from in this whole collaboration. One of the other things that has been really striking about you in your journey, how open you are to feedback. And I think it is such an important thing that we can say things as supervisors, and then always you will do something really intelligent with it, and to be afraid to give you feedback, because you always ask for it and we're open to it, and you really. I really, really enjoyed your presentation this morning, and it shows to me how mature you have become as a scientist. And I'm going to end with wishing you the best for your future. I have so much confidence that you are an excellent researcher, so we would be very lucky if you will continue in the academic field. And I would also like to echo what Ferdinand and the other jury members said today, that the field that you've been working on is really a very new and important field. I think we are really in the middle of a paradigm shift also with the children we work with. They have a childhood onset disability, but they will live much longer as an adult with this disability than as a child. And we've been focused very much on medical interventions, making muscles weaker with botulinum toxins, lengthening them, stretching them. I think we should have much more awareness of making children strong and muscles strong, and not thinking just about participation on the short term, but also health and muscle health. And I think your research is also really important to make us more aware and get us to work with this. So yeah, I think I would like to leave it here, and hope I've been able to share also with you something. Very, very nice journey that has been with you on this, and wish you all the best.
Thank you.
Fernandez. As you know, it's hard for me to speak English. So, yeah.
Yes.
So, as a amateur, I work with others, and I will express my point of attention and members of the jury. City of Saint-Étienne, my city, and then I thank you just for this presentation. Highlighting the different issues for parenting, and see the conclusion of it. So thank you. This study is very essential for me as a clinician because it's leaders. And they express a decline in performance, not only in kids, but in and they have concerns about say to me how to share it was the beginning of the see a presentation with 3 years later is it hasn't been easy for you, a new word, country, patients, and you managed to understand the civic context, and you prefer to lead them, to build their confidence. And so you adapted yourself to their difficulties and grow. It hasn't been easy to recruit patients like in the small, and we could feel actually the fields work and some things we develop and I hope that's that's obviously there's still a lot of discuss to improve. We never need in addition to give to short mind situations, and they are transitioning from the child to adulthood, best advice in teaching work. And I heard the commentary, the remarks, and John shows which are not very clear and we know that the role of sports and physical activities in sport how can it be adapted for one for each child? The accessibility to sports film with questions. It seems easy to say you have to sport with your physical activity. It's not very easy. Patients who sometimes can't drive, sometimes really no possibility to play sports. It's really an issue. But understanding the causes of the decline and the subject we are discussing now is with a lot of works here in child behavior transition, and this work is good. Just a remark about you said that two main factors will define what the balance. It's a very important factor because we see studying this. There are issues about stroke control, about modification of appendix. This affects balance, this affects if you just speak about fatigue, possibility it's after just a remark concerning your proposition to repeat a gait with your patients every 5 years. You said, I insist that big difference between CB for some years ago. As you said, things and the patients they the same. We can have because it's not difficult by children that injection of toxin can be effective. We can see it in articles. So it's relationship. Definitely, I'm not a famous soccer player. Don't even like football. Say it to you. No. I wish you much success in your professional life and much happiness in your personal life. And very easy. Okay, thank you.
Okay, so how are you? but it was fun, we were great. So I won't speak too long, so we all know that already the job of the Bruno of it's better to reach. I even need it. So I tried to prepare some keywords that may help me about you. So maybe going back to 4 years ago, almost 4 years ago, so we will do the PhD scholarship, and we were very impressed by your scientific maturity. Would be my first and yes, this impression, I think that's all the leadership and what I will aim to questions. So how well you master the defense departments. And yeah, this people with stomach. Yes, the term defense is really good. And defender but I will need to pass before talking about you. I would like to thank enjoying the way you did it from that command for in France. And just like your trust on us. That was the keyword that you organized. Yeah, this one is for us. So I would also like to thank your Hureau because yes, the official team that you, in my opinion, you were part of the team because you were a lot, and it was really a pleasure to design this study with you and by what you did. Reminded as the feeling with the patients, and we were able to design it to provide answers and action for good answers. Thanks to you, and that's back to you. So back to my keywords. Danish would be a keyword. So yes, I think it was my first international PhD student, and it was really fun to. And you came to the lab with all your Danish side, the like the shell, but you comes also with another keyword, which would be design. Because Saint-Étienne is the city of design. Just like I think diabetic. Not be the word, but humanistic, yes. For sure, we can take humanistic. And you improve the site for most their presentations, for graphics, helps providing a nice presentation. So definitely. Another word will be autonomy, because this protocol, but once we ended with the definition of the protocol, you was not only tell yourself to improve your patients, and you did it with the help of some guide. Yes, on my mind. see your work. These and maybe two last keywords would be smile, because we always did what you have to do with the slide. I'm always happy to do. You're crazy, as you would say. So it was always while smiling, and it was really to see it was for you. Was already maybe not the best one, but it will be positive as well. It's next. Because when you want something, or when you want to do something your way, you do it. So if you are not already. It's part of your quality. Also, you going like that. My last keywords would be say that you are kind the challenging parts of your PhD journey, always keeping your sights on the summit and navigating. Yes.
Feels like we come to an end, and it is the end of this first public part of the event. Now, this whole first row will retract for a few minutes and discuss the book. Thank you.
When we can meet here,
Yeah.
we can do it.
Where the hell is it? Oh, there it is. The device is currently in use. Ja, men jeg så godt, der var noget lydproblemer.
Well done, my dear.
Ja, tak.
Congratulations. You got it. I like everything and well, you really answered very well.
See you guys a bit later. Really?
Yeah.
Oh, that's really good. Ja,
I have a net.
Yes, second one I was beginning before there.
Super trend.
But I recently did a lot of first.
Great.
Cheerios. They were like there's no issue. Either understanding where we are. There's something different. But
Is it sure that, oh, you don't have enough space? Do you have a mega key? Because it's almost 5 giga.
yeah, I'm considering taking this up. It's quite wrong. I think I'm very sweaty. So.
Right, right for lot of shoes.
No,
Yeah.
Yeah. Something underneath.
Oh, yes.
Very sweaty.
It's
Hvad så? Det er godt, du kan få det. Det er skide godt.
Oh, yes. Wine.
okay.
No, I didn't see anything. I haven't. I think.
Yeah.
Yeah, but if you can look for like, because we were talking about this. So I will come back to the question. I think we will come back to the question.
Ja, det er godt til at den slamt.
Havde den spørgsmål?
Det er jo fordi, at lyden ikke er.
Did you switch batteries to the mic? Yeah. Ah, you had them.
Next up now is waiting for the jury.
Yes.
Good fun. They'll probably spend ages just to. What? Det overlader min næste der. Derovre står det. Jeg har ikke lært noget. Jeg tror bare, det er ikke det, der ligner. Jeg tror, jeg læser lige op. Ja. Altså, udmærket spørgsmål. Ja, det var fint.
Flotte slags, og ikke...
Nej, det er...
Jeg fik også lidt følelse af, at du havde med.
Det er minimalistisk. De var rigtig gode. Det må man bare sige. Ja. Men det var mest fordi... Det handlede om at få styret historien, ikke så meget om, hvordan det skulle ske. Men det skulle jeg måske snakke om.
Har I taget engelsk løbende? Har du ikke taget fransk med dem?
Jo.
Det kunne være sjovt nok, hvis du havde taget fransk.
Ja, jeg tror bare, det vi har haft de fleste møder på fransk.
Det gør det også til et sjovt setup, at vi får et Rasmus. Så det er så meget bedre end dem.
Så meget han plejer at han er god til, der er ikke noget der. Jeg tror bare ikke, det er
Nej, det er jo bare sjovt. Det er sådan lidt samarbejde.
Lige det samme, at jeg nok også er lidt stedig.
Jeg tænker, at jeg har lært dig at kende.
Ude, så men der går jeg nok. Du er som en jakke. Nej, det ved jeg ikke. Det ved jeg ikke. Det bestod sådan. Det kan være, der er meget skidt arbejde. Ja. Det ved jeg ikke. Måske. Nå, det er beauty. Det er super billigt og track. Og det er simpelthen, jeg bare ikke. Ja.
Det skal være en artikel.
Det skal være en artikel for sig selv. Det er så tilbage. Hvis du sidder, jeg har 46 prikker. For hver enkelt billede af kameraet har 1000 billeder i sekundet. Skal vi have sørget for, at de her prikker er på det rigtige sted for rummet. Det skal jeg så gøre for de her 15 personer. Ja, men de har 10, de går 10 gange hver. Og 10 skridt på hver side. Det er rigtig kedeligt.
Ja, det er interessant.
Måske. Jo, jeg tror det. Den der lurer, jeg har tanker om, det kan være.
Det falder på det godt. Ja, det kan du ikke med søvn.
Ja, det kan jeg faktisk.
Det er nu for afslå.
Jamen, det synes jeg egentlig også. Det var først, da Ferdinand kom op, hvor jeg vidste, at nu blev det noget, jeg ikke ved så meget om.
Men jeg synes faktisk, at vi stillede mange spørgsmål.
Ja.
Jeg snakkede meget igen.
Ja, men jeg tror, det er super spændende, at lave.
Okay, men de har jo alle sammen også det der med aldring.
Ja.
Som virkelig ikke den første. Og var det fedt, hun havde spørgsmål om slides.
Ja, det var rart.
Det gør jeg også meget med at dynamik i rummet. Vi bliver meget mere involveret.
Ja, så ikke sidder en kigger på.
Jeg tænker bare, at der er også så transition og alt det der turn, og der er så mange i 100 år. Der er bare mange. Det er ærgerligt at blive voksen til, så bliver det bare smukt.
Men det synes problemet er, at når du bliver voksen, så er det dig, der får det. Det er dig, der skal arrangere det. Det er dig, der skal komme til det.
Det er også træls, at det er i stedet for, at du får videre med dig.
Ja, det er transition.
Det er vildt. Hvis man allerede nu kan se, at det er meget bedre at være set end 40 år.
Det tror jeg.
Hvad er jo
Det vil sige, at deres muskler bliver korte, så laver de muskelforlængning på typisk baglåret, men også i hasen. Mange af dem de går sådan her, så fordi de har helt korte muskler. Eller de går sådan her på stylter, fordi den er spændende. Så laver de sådan en muskel, men så opererer jeg skal sidde helt på nogen. Vi ser i gang, og det ligner, at det er noget nerve, men det ligner, fordi at man kan bibeholde sin gang. Jamen, det ligger der. Altså sådan, basalt ligger det i rygsøjlen.
Jeg har sådan et fedt digt, der skriver.
Der er lidt nogle kopper.
Kan vi ikke bare tage de der kaffekopper?
Jeg tænker, jeg tror, jeg skal hente noget med den der.
Ja, der er sikkert godt.
Non, pas pour le gars. C'est celui que j'étais tout là.
En anden bygning. Folkens online. Hygger jer. Nej, jeg tror folket er ved smut. Nej, det er rigtigt.
Ja, det gjorde han.
Jeg synes faktisk, at
De andre også, men de er bare meget...
den var bare meget sol. Men mere vand.
Det går ikke siddende på det.
Merci, c'est un peu ça, monsieur. On va voir.
Moi, j'ai fait la réserve sur ça.
Ah, et la
C'est ici, là.
Sur les théories, oui, normalement.
Tu dois prêter ça.
Ah, c'est quoi spécialement?
Probably for moi, Gabi for you. This is what they're reading for me, so I'm expecting.
Ja, men Tom, die kan spelen.
What else? Like, if you don't do that, you cannot be doctors. By this university, at least. That's on the road too much.
La Maître analyse.
Den med test.
That's why I said I thought you mixed up French and English. And I was like, sounded like a sentence.
Tes parents, ils sont...
Oui, là-bas, les mélanges.
Ah oui, toute la famille. C'est bien complet.
C'est super. Et il y a le Ferdinand aussi.
D'accord.
C'est sûr. Les monstres.
Les Danois, ils sont pas plus froids, Dan.
Il fait pas à l'intérieur. Pas à l'intérieur.
Mais bon, d'ailleurs, c'est justement.
C'est ça, non, mais nous, ici, on a
D'habitude, t'es froid.
Je pense qu'ils ont pas changé.
Aussi.
Les autres.
Ah, mais c'est comme tu pensais, David.
Moi, je crois que c'est comme une.
Compliment.
On a la même. Elle un peu.
Ah, oui, c'est vrai.
Ça va.
Pourquoi il ne les mange pas?
Pas on n'a pas.
Vous avez la pluie
Jamais. On n'a pas vu.
Faut mieux essayer.
Oui,
même si vous avez aussi compris la différence, comme dans les pays très nordiques.
Oui,
Ça se présente encore plus tôt aussi.
Ouais.
Hop. I have no idea. The video doesn't work anymore.
Er det fordi, der en ekstra der nummer på? Det er noget
Nå, det er tilhørsforhold. Det er et tilhørsforhold. Hvad så er det?
4-5, hvad vil I sige?
Jamen, det er Annemike, hun er.
Skal vi bare gå der?
Nej, det ved jeg ikke.
Sans les délibérés. Mais tu sais,
Fordi du vil tage derinde. Det kan bare være, jeg ikke gider vente. Nej, det skal jeg ikke. Jeg vil bare pømme der pølsen. Og det var meningen, at klokken 12 der skulle alt være færdigt. Jesus et maraton.
Jesus. Jesus.
Hvad med brugeren?
Jeg har ingen anelse.
Det er en anden, der skal sige det.
Det kan være, det er Mikkel.
Nej, det står see you later for me. Ja. Hvad siger hun, Martin? De andre også, men er det ikke kun Julie, der skal se?
Jo, men de andre har også
bare
stik med siden af. Ej, der er ikke nogen, der gider at sidde og se.
Gode. Ja, der er mange, der gik løbet.
Ja. Halvdelen. Les amours.
Ça, mais du coup, c'est en français.
Bah, mais.
Et sinon, et là, du coup, de mon du docteur 1. Et toi, ça sera quoi sur ton diplôme? Sciences.
Bah, c'est 6.
Elle dit, ouais, sciences d'ingénierie santé.
Ingénierie santé.
Ouais.
Biologie et physiologie et l'exercice.
At
least for me.
Ouais, mais je pense que ça va être la même.
Bah, mais. N'importe.
Biologie et physiologie. Est-ce que tu parles? But I told you that she planned some slide, like, yeah. But I didn't thought it was like some slide too, like I felt that it was her slides with all the questions.
No, I was thinking as well.
Nice.
But it also worked quite well to keep it on my computer, I think, just to have it easily presentable. Because I knew if she was starting, then I would want to go back to my slides. And then we didn't even get to talk about all the slides that I have here.
You didn't?
I only got to talk about this one.
You changed your presentation to like in between?
I removed all these slides, then I updated this, and then I didn't update it since.
Okay.
But here, relative workload is the first stage. We talked a bit about EMG as a proximate effort. This we didn't talk about. I wanted to talk about this.
Yeah.
And then if you wanted to talk about muscles, then I had a couple of studies.
Yeah, they were more interested into.
But he's. And then this we spoke about yesterday. But I mean, there's so many measures missing because I thought about using it, but then I didn't want to use it.
Read it from there.
Oh, that's a good idea.
So, or maybe you can just put it there already from the screen. There you go. You can probably do of thunders answering the question saying, bah. They should be
but they're just having fun.
around the door.
No, no, no.
They want to.
Just having all the fun.
How is that going? Yeah, but
You play.
I hope we do. I don't know. Otherwise,
exactly.
Something serious.
So we in the jury, we've taken a few minutes to summarize our perception of today's performance and the material that we've read. It's my task now to try to summarize this in a few words and then let you know if you passed or didn't. I would say for people who haven't attended a lot of these things before, this was a good performance. It's actually an excellent performance. We were really impressed by your verbal skills and your way of communicating. This was a long defense also. It's in 3 hours plus. You said your mouth was dry, and sometimes you also that your brain is getting a bit dry at the end, but this was not the case with you. You like talking, we could see that. And the defense, if it's 3 hours long, I mean, it will also touch upon very different subjects. We've touched upon methodological issues with your work and considerations that you had to do. Ranging also subject-specific things like nature of fatigue and how to assess it, muscle, what does it look like on the inside, and also the nature of the condition, the nature of the disease or disorder, I should say. We were also impressed by your presentation, very clear slides. And it's not easy to summarize 3 years of work in a coherent way in 45 minutes. You kept the time. That's also good. I should say that we were all impressed by the level of clarity in your answers. You took the time to answer. As we said, we see that you like talking, and when we're scientists, we call it scientific discourse also. You know, the ball goes back and forth, and you can talk for hours, as we've just done. So it is the verdict of the jury today to congratulate you on the degree of doctor at the University of Jean Monnet, Saint-Étienne, in biology and physiology of exercise. And before we conclude now, it is local custom, or maybe French, to hear you give the ethical declaration.
Yes. C'est quoi? Ça va être en français. En présence des militaires, parvenus à l'issue de mon doctorat en physiologie exercice, et ayant un type pratique dans ma quête de savoir, l'exercice d'une recherche scientifique exigeante, en cultivant la rigueur intellectuelle, la réflexivité éthique et dans le respect des principes de l'insécurité scientifique, je m'engage pour ceux qui dépendront de moi dans la suite de ma carrière professionnelle, quel qu'en soit le secteur ou les domaines d'activité, à maintenir une conduite intégrée dans mon rapport au savoir, mes méthodes et mes résultats.
Well, perfect. French, huh? Congratulations.
Thank you very much.
Wait, you may say a word.
I can say a few words.
You want the mic?
I can talk some more. Perfect. No, I don't want to mic. Well, obviously, thank you to my primary supervisor. You talked about autonomy. And I remember one of the first things she said to me is, I don't care when you work, as long as you reach your deadlines. I haven't heard a word from you ever about when I worked. Because when I worked has been probably off the typical French working hours. I've never heard anything from it, and it's super nice. It's really been a pleasure to be given this autonomy, to be, just have your faith in me doing what we agreed upon. And we might have missed the deadline. I definitely did. And you being patient with all my issues with French or French navigating in France or getting a deadline or missing something. Thanks a lot. It's really it's been a pleasure, and I might have learned something also about diplomacy. Sure, I might have gotten slightly more diplomatic. Not sure that much, but just a little bit. Bruno, heck of having a clinical doctor who questions everything that we have done, or why we do it, or why we do it like that. It's been really good, and we've disagreed a couple of times, but it's been very nice. And every time I thought that, hey, it's getting better because we have this clinical perspective. I can get frustrated, but it's definitely everything's getting better because I get your insights to why is it we do this and why is this important for the participants. I would have never been able to invite all these participants in if we hadn't spoken before about what might be the issues, what might I have to expect, and why are we interested in this measure. It's been really widening what I have found important to have you and also Enrique as clinicians who says, well, this is actually important to the patient, not just to the researcher, because I'm very much on the side of Thomas, being, well, we have to measure it objectively, and then we measure it, and then we conclude. But the insights, it's been super nice. And Enrique, thanks a lot for joining and for having me in Amsterdam. We changed a couple of minor things in the protocol after having spoken with you. I also have a ton of markers to track. I'm not that happy about it, but that's also thanks to you. It's been nice having someone who's on the outside, joining, having an overview, and then having an outside perspective saying, well, what if you look at it from this way? It's been quite helpful, and I think I might have gotten some of my more minimalistic design ideas true due to you saying, but it could work. I don't know. The same can be said for Yuki as a proper outsider in this thesis. It's remarkable seeing how when we send articles around that your feedback is spot on and exposes any of the flaws that might be in this discussion. I think we mostly spoke during the first half year and then during this last half year. And it's been pretty much on methodology, and because, well, obviously cerebral palsy is not your area of expertise, but very nice. Finally, we have all my dear colleagues who make it very fun to go to. I really enjoy being here. Yeah, super nice. And so nice to see you all the people. Family, very nice of you to come. I am thrilled that you will come on a Tuesday to see me talk and now I'm talking some more. And finally, Olivia, thanks a lot for keeping up with me. I might not have been the easiest to be with for the last year, so that's super nice. I'm happy to have discussed every single, I mean, if you have heard me discuss things, Olivia has listened to all of it. Every single thing. And it's been really great. And I look forward to living with you. I think I have nothing more to say. I'm done for. I think we should go eat some cheese and sausage.
Perfect. Sounds like a plan.
And thanks to everyone online. We're leaving now.
I'm very good.
Ja, jeg vil gerne gøre i år.
Ja, det ved jeg godt. Det er jo skide sjovt at have. Der er blandt andet med over for nogle bøger, før I skal afsted.
Congratulations. So happy to be part of it, of those.
It's
And you did so well today. I think you enjoyed it. Yeah.
great.
Congratulations. Congratulations. Thank you for helping.
I mean, any
We can just have